This is 4.1.5, Newton's laws. As part of your A-level, you need to know Newton's laws of motion. That's Newton 1, 2, and 3. And you need to know how to apply that to solving problems in questions. So, Newton's first law says that an object will remain at rest or constant velocity unless it is acted on by a resultant external force. Put a box around that. So, if we have an object, it will carry on doing whatever it was doing unless a force, a resultant force, is acted on it. Which means that if forces cancel each other out, there is no resultant force, so it carries on doing what it was doing. In other words, if I take a hammer into outer space, and I just leave it there, it stays in its position. If I throw the hammer in outer space, and it leaves my hand at some velocity, it carries on moving at that velocity forever. Unless something else applies a force onto it. But assuming it's far away from any stars or galaxies or planets, it's not going to experience any forces, and therefore it will carry on moving at that velocity forever. Next is Newton's second law. This is a simplified version of Newton's second law, which is that the acceleration of an object is inversely proportional to its mass and directly proportional to the applied resultant force. This is describing the equation F equals to ma. The proper version of that equation is actually F equals to delta mv over delta t, which means that force is proportional to the rate of change of momentum. Next is Newton's third law. And Newton's third law says that every action has an equal but opposite reaction. Newton's third law might sound like it's the simplest of the three. But actually, Newton's third law has a few things you need to consider. Because sometimes what you think might be Newton's third law actually is not Newton's third law. For example, if an object is on the ground, gravity pulls the object down, mg. There's a resultant force on the object due to the ground it's standing on or sitting on, which points upwards. Now they're equal in magnitude, but those two forces are not a Newton free pair of forces. to be a Newton free pair of forces, it has to meet these conditions. Number one, they have to be equal in magnitude. Now the example I gave is equal in magnitude. Number two, they must be in opposite directions. Again, the example I gave meets that condition. Number three, it has to act on different bodies. And this is where the example I gave doesn't work, because I said the object experiences mg downwards and the object experiences a resultant, a normal reaction upwards. They're both acting on the same object. So that's not a Newton free pair. And the fourth condition is that they must be the same type of force. Now mg is a gravitational force. It's a non-contact force. Whereas a normal reaction is a contact force. So they're not the same type of force, therefore they cannot be a Newton free pair. So, to be a Newton free pair, the forces must meet these requirements. Equal in magnitude, opposite direction, same type of force, and act on different bodies. That's the end of 4.1.5.